how do zeros and ones, or simply on and off switches, make everything possible in our digital binary code world? Well, to understand this concept, let's think about our own human communication. So we use millions of references, such as words and letters, to learn and communicate. So for example, 26 letters in the English language have helped us write millions of books, tell stories, create religions, science, medicine, and innovation. So similarly, a computer is nothing more than a box with billions of transistors that are simply on and off switches. But instead of calling them on and off switches, we will call them binary code, where 0 is the symbol for off and 1 is the symbol for on. Knowing this now, we can tell the computer, "Hey computer, here is a book for you to understand how to talk to me as a human. So I want you to represent the combination of 1, 0, 0, 1 as a tennis ball, and the combination of 1, 1, 1, 0 as a taco." So the computer says, "Okay, from now on, 1, 0, 0, 1 is a tennis ball, and 1, 1, 1, 0 is a taco." Much like the alphabet for us represents an almost infinite amount of possibilities when you combine different letters in different ways, a combination of zeros and ones in unique and specific ways is a reference for a computer that could be perhaps one of the 26 letters in our alphabet, or maybe a pixel's color and location on the computer screen. Everything comes down to a reference, a mathematical Rosetta Stone, if you will, for us to interact with our digital devices instantly and understand each other. So with this binary code, we can tell the computer to represent a combination of zeros and ones as something else, just like how we use letters to represent words. This is where ASCII comes in. So ASCII is a set of rules for how computers can represent letters, numbers, and symbols using a series of ones and zeros. So each letter, number, and symbol is assigned a unique number called a code point. And that code point is represented by a combination of zeros and ones. For example, the capital letter A is represented by code point 65, which is represented by the binary combination of 1, 0, 0, 0, 0, 0, 1. While the lowercase letter a is represented by the code point 97, and the binary combination of that is 0, 1, 1, 0, 0, 0, 0, 1. It's my robot, by the way. But how does this all come together to make our favorite apps and programs work? Well, it's actually all about layers. So at the very bottom is binary code, the language that the computer's hardware understands. Above that is assembly language, a low-level language that is easier for us humans to read and write. It's like the scaffolding around the building, providing a more accessible framework for the construction work to happen. So above assembly, we have more sophisticated, high-level programming languages like C++, Java, and Python. These languages are closer to human languages and make it easier for developers to create complex software without dealing with the details of the computer's hardware. It's like the walls and roofing of a building, providing protection and comfort for the people inside. And at the top of this stack are the applications we use every day, created using high-level programming languages, but still executed using the binary code that the computer's hardware understands. It's like the people and furniture inside a building, the final result of all the hard work that went into creating the structure. So in the end, it all comes down to a simple idea, a combination of zeros and ones that make up everything we see and do on our computers.